Hey everybody, this is Larry. This is day 23 of the September Leetcode Daily Challenge. I'm only 10 hours behind, so I guess I'm not that bad. Like 11 almost. Hit the like button, hit the subscribe button, join me on Discord. Today I'm a little bit late because I spent most of the day hiking, and it was fun. You should, and if you want to find out what happened, hit me up on Instagram, read the stories. It's a long one, I'm not gonna lie. But I probably was closer to death than I would have liked to admit, but at the time, it didn't really feel like it. Yeah, anyway, hope you're doing well. But yeah, thanks for just checking in. And yeah, let's get started on today's problem. Let's see, break the palindrome. I guess I should have been loading it. Hope everyone's doing all right. Today's Thursday. So yeah, internet in this place is a little bit better. I'm in the Spanish region. I want to say Asturias. I don't know if I'm probably saying it incorrectly. Covadonga. That's where the lakes are, and it's beautiful. Today is a little foggy, unfortunately, so I don't think I have very good photos, but it's still a fun experience. And sometimes that's all you need. Anyway, okay, finally loaded, and today's problem is break a palindrome. Okay, so given a palindrome, we place one character of any lower place so that result is not a palindrome, and that is the lexicographically smallest one possible. This seems like a one of those stupid trick questions. Maybe let's see. To be honest, because yeah, okay. There's no way to return an empty string. Okay. Mm, yeah, I mean lexicographically smallest or largest. Okay. Hmm. So it's not that bad. I think this is brute forceable. The thing is that you only need to do one string or one character at a time. Yeah, and then it's just about. I mean, brute forceable because you only need to change one character, right? So at worst, it's going to be 26 times 1,000. Yeah. Actually, I was going to say that's interesting. My original thought was that you can probably do it in a way such that you always enumerate in a way such that it is lexicographically smallest. And I think you can do that. But to be honest, also, if you're just doing 26 times 1,000 and then you're just doing some checks on that, you'd probably be okay unless you're doing very slowly. Even like 26 times 26 times 1,000 times 1,000, which is 26 million. It's going to be fast enough in most languages. Maybe not Python though. So, but in theory, I think we can do this in a brute force kind of way, and then just check whether the word is a palindrome. I think it makes sense to greedily, um, and I think probabilistically, you only need to, like for 1,000 characters, you only need to check half of them anyway, because I don't know. I guess stuff like this is the only case where it'll be in the second half. Yeah, maybe I'm wrong on that one actually. I think A is the only string that makes it in the second half, maybe. Oh, no, I'm wrong on that too. Because here, if you change A, it will be a palindrome. So maybe there's some edge cases. Okay, so I mean, I think I would say though, so I think there is one special case. There are a couple of special cases. I'm about to sneeze, so I apologize in advance. Hang on a second. I'm like in between sneeze. Hang on. Okay. So I needed to get that out of the way. Yeah, I think the idea is still brute force, but you just have to be a little bit smarter about the middle character. I think there are a couple of edge cases that you can consider, and I'm just thinking about how to implement it in a fun way. If I was in a contest, to be honest, I would just ad hoc maybe if statements to check for these couple of cases. But yeah, I think the thing I would do is For each, maybe the more maybe one way to do it is that for each character we check to see if changing this can be made into a palindrome. If changing this can be made into a palindrome or not a palindrome, then we should change change it to the smallest one possible, and then we just switch between the 1,000. 1,000 is a lot though. No, you just do a min on 1,000, so that's fine, maybe. I'm also just trying to think about optimizations to make sure. But yeah. So I mean, for lexicographically smarters, you have like these weird cases here, where if you try to greedily shift the earlier one. But I think that only happens to A. If you switch A to B, or yeah, I think maybe that only happens to A because everything else you can switch it to A. So I think the only special case is from A to B. From A to B, then now you hold it on and then do a later one. Okay, let me think. I think that's right. Now let's do the implementation. Okay. So okay, let's just do n is equal to the length of the palindrome. Okay, so then now for index in n or in range of n. Okay, so then we want to ask the question is, can changing this character make a palindrome? Right? And here we have two cases, right? If I'm going to rename this P just because it's going to be annoying to type. So if P of I is equal to A, then we do something, and then else we try making this. I think there's additional weird case as well. Wait, and that's yeah. Oh no. Okay, so they give you a palindrome string. I was going to say that if they give you a random string, you might have to do some weird, or you just need to check to see whether it's palindrome to begin with. But I guess that's not necessary because they give you a palindrome. Okay, I just want to make sure. Some problems they just try to trick you, right? Okay. So in this one, otherwise then this is done. If this P of I is not equal to A, then I think we can just set it to A and be done, unless it is the middle character. Because you can have something like B. No. You can have something like A, you know. Actually, I guess just this example, right? If you go point to the, if you're here and you point to the B, then that's no bueno, right? Okay, so man, maybe we just do the first half, and then we have a different logic. Okay. So we know that this is palindrome. So what is if the first character is an A, then we skip it in the first half. Okay. Yeah, okay. So I'm also just trying to think about the even and odd cases. I'm really bad about whether this checks it. I think that this does not check the middle one, so that's good. But okay, if this is A, we just pass because this is in the first half. So then here we just do, this is not equal to A, then we set, I mean, this is not quite syntax, but we do effectively this. And that should be good, right? And then we return P in the first half. I know I'm going a little bit weird because I'm thinking, I'm not articulating it very well today, but I am going for a lot of different scenarios in my head. It's what I'm like pausing for and just thinking of like, okay, if this happens, if I write it this way, does that work? If I write it that way, does that work? And so forth. So yeah. Okay. So this is the shorthand. This isn't quite right. So that's why P is equal to P sub I minus 1, something like this. Is that right? That's one to code. I have to type in all the settings. Okay. I know those aren't the examples. Actually, okay, they are the examples. I was wrong. Well, there's one more one character, but yeah. Oh, did I meant to take this out obviously because I knew that this was in it. Wow. I mean, it's just gonna be none, so that's fine. Though this is taking a while. It may be because my internet is slow as well. Okay. I'm just wrong here as well. Is it 2i? Internet is slow, internet is slow. What am I gonna do? Oh, that is actually quite fast. Okay, so it seems right for this one. But yeah, but I have to do it for the other ones. This is. Oh no, that's the wait. Why is that the expected? Oh. Let me think. Is this only the? I forgot about this case, but I want the not possible case. Is that only for n equals 1? Because for n equals 2, you can always choose either 1. For n equals 3, of course. So yeah, so okay, so this is with n is equal to 1. Okay, so we got that case. And then the other ones, we knew that this was going to be in the second half, right? So, okay. So the middle character, I guess we never switch the middle character, right? Because we never switch the middle character because we never switch the middle character because it would never switch the result. Like the exact middle, not because okay. So then now we just do for I in range sub the other half, I guess. But then we add it. Yeah, I'm really bad at this whatever stuff, rounding error. Let's see. Maybe something like this. +1 or something. I don't know. Something like this. Okay, so for 5, it gets 3 to start, right? So that should be okay, maybe. Let's just give me out of bounds. Yeah, I forgot that this is solo slow. Okay. Okay, so it doesn't give me an out of bounds. That's good. I guess I should just print it. Sorry, friends, I'm a little bit slow today. No, this is a silly problem. But it's just case analysis, though. It's not nothing too tricky. So A, maybe? I don't know. I don't know if this is the right. Okay, that's just my debug. Because multi-cases is a little bit odd, and I'm just really bad about it. Wish this is local, or there's a way to local it. I mean, I guess there is a way to local it, but I just don't do it. Okay, so A, okay. So we don't worry about the middle character, so I think we're good here. So, okay. So now what do we want to do? Okay, what are the cases? If it's A, so that by the time it gets here, that means that all these are A's, right? Except for the middle character. So that means that actually, maybe I don't even need this. If there was no non-A characters, then the last, we just switch the last A to B, right? And the last A, yeah, I mean, and it has to be the last character. So then here we can just return P to the -1 plus B, right? Is that right? Can that be right? Am I missing any cases? I'm thinking right now. I'm not really thinking right now. I'm just waiting for this to finish. Okay. So let's give it a submit. Am I good? Let me think. What other cases can there be? Every other, well, let's try one of the obvious cases, I guess. Like obvious cases that doesn't have A and B, because I think they gave us a lot of A and B cases to confuse us a little bit. I just wanted to see an obvious one. Okay, so that's good, I think. Yeah, okay. Sometimes I just miscount. All right, let's give it a submit. Sweet. As you can guess, this is O of n because we do a loop, and we do a loop, and then you also do a string concatenation thing, which is O of n. So this is going to be O of n. This is going to be O of n space as well because of this. So yeah, and I kind of wrote it backwards. I think we could just return this, but what did we need? Well, yeah, but otherwise, this is pretty much it. Yeah, linear time, linear space. Don't think you can do any better than that because you just need to read and give the output. So yeah, that's what I have for today. Hope you stay good. Hope you stay healthy. I'll see you later and have a great rest of the week. Bye-bye.